Where are the others? Only 23. Meaning, I know you are joining in groups, but there should be more than that. No? Anyway, it's 8-5 now. Shall we start, students? Can you hear me?
Yes, sir.
Okay. You can see the screen also, no? Can you see the screen? Oh, well,
Yes, sir.
okay. Good morning. We shall start. I have to record now.
Recording in progress.
Good morning, students. Last time, let us start. Last time we did a trace of a matrix. Just to remind that transpose of a matrix, not trace. I'll tell you what trace is also later. Transpose of a matrix, transpose of a matrix A is denoted by A T, like that. Superscript T, A transpose. How do we obtain the transpose of a matrix? If we take A to be, for example, -1, 3, 2, 5, 7, 9. What is the transpose of this matrix? Let A be this. Then transpose is obtained by, yes, what is A transpose? This is what is the size of the matrix? A is of size 3 by 2, 3 rows and 2 columns. A transpose would be of the size, what is the size of A transpose? 2 by 3. Because A transpose is obtained by interchanging the rows and columns of A. First row of A would become, in the transpose, first column. So what is the first column of the transpose? First row is -1, 3. Therefore, first column of the transpose is -1, 3. Second row becomes the second column. Second row is 2, 5. So it is 2, 5 here. Third row, 7, 9 becomes the third column of the transpose, 7, 9. Do you all understand it? කතා කරන්න පොඩ්ඩක් කවුරු කට්ටිය ගොඩක් එක්ක ඔයගොල්ලෝ ඉන්නවා ඒ වුණාට it's better. Do you understand it? නිකන් yes කියලා කියන්න. Yes now. Yes? Do you understand how to write the transpose of a matrix?
Yes, sir.
Okay. Suppose in general, this is how we define it. If if A is Aij m by n, what is the meaning of this when we say if or let A be Aij m by n? This is that whole big thing. A11, A12, A1n, then A21, A22, A2n, last row AM1, AM2, last entry is AMN. That huge square, huge rectangular arrangement is denoted by this. Then what is A transpose? A transpose is equal to AJI n by m. It essentially says what we did here. It exactly says what we did there. Okay, so ijth entry of the transpose is jith entry of A. Okay, so that means the rows and columns get interchanged. Some properties of A transpose. This is easy to see. First one, what is A plus B transpose? What do you think? A plus B transpose is the same as A transpose B, transpose plus B transpose. Okay. Second one, if it is minus, we know it is minus, so let us not waste a line for that. Ka transpose. Ka transpose is the same as K times A transpose. So constants can be pulled outside a matrix now. Okay. So if K is common to every entry of A, it will be common to every entry of the transpose also. Okay, here it's easy to prove. Anyway, we'll complete it and say ATT. Nothing can tell me what is A transpose. Can somebody guess? What do you do when you take A transpose? You interchange rows and columns. And then again you take the transpose, meaning you again interchange rows and columns. Where would you be after doing it twice? Now go to this example. If A is this, we wrote A transpose. Now what is A transpose of transpose? I said if you take the transpose of this again, you would have to interchange rows and columns. First row becomes first column, second row becomes second column. Where what will happen? If you interchange this to a column, it is this column. If you make this a column, second column, it will be this. So A transpose is equal to, yes? What is A transpose?
A.
That is right. A. Very good. The fourth property is a bit surprising one. Okay. Now I want to multiply. Whenever I write AB, what is the compatibility condition? Number of columns of A should be equal to number of rows of B. Okay, to multiply. We know if A is M by R, then B should be of the size R by N. Then AB multiplication would become an M by N matrix. We did that slowly last time. No? So now if you take AB transpose, AB transpose, it is not equal to A transpose B transpose. The order gets changed. This is equal to B transpose A transpose. This is a common thing in a sense. When we talk about inverse of a matrix, AB inverse would be B inverse A inverse, not AB inverse. So this property, to illustrate that, let us do a quick example. Okay, these are also, I will handle them through the tutorial problems. I will give an example for a example of a matrix A and B and ask you to verify that A plus B transpose equals A transpose B transpose. Just to, I mean, when we do things like this, you think you have to just memorize them without any understanding of what is happening. Just let me just take the plus sign and try to explain what happens. Suppose A is equal to Aij m by n, and B, let us write it as Bij m by n. Why do I have to take B to be of the same size? Because we want to talk about A plus B. Yeah? A plus B. So what is A plus B? A plus B is equal to, A plus B is equal to, what is the ijth element of A plus B? Aij plus Bij m by n at the corresponding entries. That is A plus B. Now find the transpose of all three. That will be basically the proof of one. Now we want to show A plus B transpose is equal to A transpose plus B transpose. Right. Part 1, A plus B transpose. So A plus B is this. If A plus B is that, what is A plus B transpose? Now write all three transposes, then it will be clear. What is let us write all three transposes. A transpose, then you will understand. A transpose is equal to, A is Aij m by n. So A transpose is Aji n by m. What is B transpose? B transpose is equal to Bji n by m. And A plus B is this. No? What is A plus B transpose? A plus B transpose is equal to, A plus B is this. Now we have to change. This is like Cij. So to get the ijth entry of the transpose, you have to interchange Cji. So I and j should be interchanged. So what is A plus B transpose? Aji plus Bji n by m. Now we know this can be broken up. Remember, this plus this became that. Okay, so here also is sum of, what is this one? This is equal to, break it up and write Aji n by m plus Bji n by m. That is equal to, this is equal to, this is the same as A transpose. A transpose plus, this is the same as B transpose. A transpose plus B transpose. So, I give you an example to verify, but here we have proved A plus B transpose is A transpose plus B transpose. A plus B transpose is A transpose plus B transpose. This now you can try to prove. This also you can try to prove using Aij notation. Okay. Last one, that is a little bit involved. Therefore, I will show it to you using an example. We can prove it also, but the notation gets a bit difficult. So it's better to verify that through an example. But interested student can try to prove it, and then if there are any difficulties, you can WhatsApp me, we can discuss, and then you can post it for others to use also, see also. Okay. But let A be, let capital A be, say 1. I want A B, yeah? So 1, 2, minus 1, 0, 3, 1. Let A be that. So this is 3 by 2 matrix. And let us take B to B, B to B. This is 3 by 2. So number of columns 2. Here it should be the number of rows. Number of rows. Number of rows only 2. So 2 by 2 rows. Let us say 1, 2, minus 1, 3, 0, 1, 4, minus 2. What is the size of, let A be this and B be that. Size of this is 2 by how many columns? 2 by 4. Okay. Now let us see the issue that comes up. Okay. Issue that comes up. Here I have taken 2 by 4. Now what is AB? What is AB? AB is going to be of 3 by 4. Let us write AB, but AB transpose, yeah, B transpose. AB is defined, but not BA. BA here, if you write B first, then 4 columns. Then the other one should start with, other one should have, if the columns here is 4, if you want to multiply B by A, the other one should have 4 rows. This one has only 3 rows. But for AB, no issue. What is AB? AB is, since they are written here in that order. Otherwise, you have to repeat it here. You get confused otherwise if you want to multiply B first and A second. A first and B second, they are written here. So we can straight away write AB. AB is going to be of the size 3 by 4. 3 by 4. 3 rows and 4 columns. 3 rows and 4 columns. Okay. What is the entry here? 1, 1 entry of AB. First row, first column. So take the first row from A and first column from B, multiply as we do in the dot product. A 1 times 1, 2 times 0. So 1 times 1 is, this is 1. Okay, you help me later. This times this would be the 1, 2 entry here. 1, 2 entry. First row, second column, multiply 1. So 2 plus 2. 2 times 1 is 2. 2 times, so that is 4. That is AB, second entry. And then this one times this. You take columns from that, rows from this. So this row and third column. So first row, third column entry. 1 times 1, minus 1. 2 times 4, 8. 8 minus 1, 7. 1, 2. Multiplied by, this is 1, 4. So 1 first row from this one and fourth column from this one. 6 minus 4. 6 minus 4 is 2. Okay, now can somebody tell me this entry? In the product, second row, first column. In the product, second row, first column. So second row from the first matrix and the first column from the second one. So do that. -1 times 1, -1, this is 0. So this is -1. Can somebody tell me this entry? What is the place? Second row, second column. So from the first one, second row, from the second one, second column. Two entry. So second row, first column. Second row, second column. Two entry, second row. So -2. The other one is 0. This times this minus 1 plus 1. This times this -3 -3 0. That is -3. Then somebody tell me this entry. Third row, first column. But just want to check. Yes? What is the answer? It's easy. This one. Third row from the first matrix. Third row, first column. First column from the second one. Multiply out. කවුරුහරි අන්තිම row එක කියන්නකෝ මේකේ. කවුරුත් නැද්ද? Yes? 3? Yes, please. Go ahead.
7.
3. This one times this. This is the third row, first column of the product. So third row is taken from the first one. First column is taken from the second one. What is the entry that you need? Tamil speaking students, what is the entry that you need here? It is the third row, first column of the product. So third row from the first matrix and first column. Third, 3, 1. First column of this. Multiplying. So third row, first column. මේ දෙක වැඩි කරාම එන්නේ මොකද්ද? වැඩි කරලා එකතු කරනවානේ මේකෙන් මේක වැඩි කරනවා මේකෙන් මේක වැඩි කරනවා ඊට පස්සේ ඒවා දෙක එකතු කරනවා. You multiply this by this and this by this and add. 3 times 1 is 3. අමට අනිත් එක කියනකොට මට හරියට ඇහුන්නේ නැහැ මේක කියන එක. Second one කොහොමද එන්නේ? මෙතන place එක. 7. Let us see. 3 times 6. Yes. So first, third row, second column. 3 times 6. 2 is 6. 1 times 1 is 1. So 7. Excellent. What is this one?
+1.
Minus 3 plus 4. Minus 3 plus 4. It's plus 1. Yes. Good. Last one.
7.
3 times 3 is 9. 1 times -2 is -2. 9 minus 2 is 7. Very good. So that is AB. So what is AB transpose? AB transpose is equal to, now this one is of the size 1, 2, 3, 4. 3 by 4. We knew that from the beginning. 3 by 4. 3 by 2. 2 by 4. When you multiply, you get 3 by 4. 2 disappears. So this is 3 by 4. 3 by 4 matrix. So transpose is going to be 4 by 3. So first row becomes first column. 1, 4, 7, 2. Second row becomes the second column. -1, -2, 1 minus 3. Third row becomes the third column. 3, 7, 1, 7. Okay. So that is clearly 4 by 4 by. You don't have to put the size 4 by 3. So that is AB transpose. Now AB transpose must be equal to B transpose A transpose. What is B transpose? Let us take B transpose. Let us write A transpose first. No, we want B transpose. No, so take B transpose. B transpose is going to be 1, 2, minus 1. Sorry, B transpose. I need the B. No, B is this. So this row becomes the first column. The row is what? 1, 2, minus 1, 3. 1, 2, minus 1, 3. The first column. Second row is 0, 1, 4, minus 2. It becomes the second column of B transpose. What are the numbers? 0, 1, 4, minus 2. 0, 1, 4, minus 2. It is a matrix of the size 4 by 2. 4 by 2, no, 4 rows and 2 columns. Now write A transpose. A transpose. A is 1, 2, minus 1, 0, 3, 1. So 1, 2 becomes the first column. So A transpose 1, 2 becomes the first column. 1, 1, 2. What is the second column of A? Second column of A is minus 1, 0. Minus 1, second row of A is minus 1, 0. It becomes a second column. This one is 3, 1. Okay, third row, 3, 1 is the. What is the size? 2 by 3. Now think. If I wanted to get A transpose B transpose, I cannot even multiply. A transpose B transpose is not defined. AT BT is not defined. Why? It's not defined. Why? A is of the size, A transpose is of the size 2 by 3. B transpose is of the size, B transpose where? 4 by 2. 4 by 2. These two are not equal. Therefore, it is not defined. So A transpose AB transpose cannot be equal to A transpose B transpose. Do you all understand it? That those two, A transpose B transpose is not even defined. This side we can find, we have found A transpose AB transpose, sorry. We have found AB transpose. But that is not equal to this order in which they appear. A transpose, B transpose, not equal. That is, it's not even defined. Now, what we are saying in that property is that, but AB transpose is equal to, we are saying B transpose A transpose. So I have AB transpose here. Huh? AB transpose is there. Now I have written down A transpose and B transpose. So this order is not correct. Now let us find B transpose A transpose. B transpose A transpose is equal. B transpose is this. A transpose is that. Can be multiplied. See, 2, 2. So answer is going to be 4 by 3. Multiply and tell me the numbers. This times this. What is the number? AB transpose. AB transpose is this. AB transpose is this. We are trying to check. We are saying it's equal to B transpose A transpose. B transpose A transpose. This times this. Answer is 1. 1. This times that. Again, -1. This times second one. -1. First row, third column. Multiply, you get 3. Then what is the entry here? Second row of this. This is 2, 1 entry. So 2 means second row from the first. 1 means first row of the first column of the second. 2, 1. So multiply, you get 2 plus 2, you get 4 here. 4 here. Multiply this by this. That is the order. See the order in which I have written them. Huh? So -2. This times this. 3, 6, 1. What am I doing? B transpose O2 this time. 6 plus 1, 7. Then there are 2 more. Third row, first column is 3, 1 entry here. Third row, first column. -1 plus 8, you get 7. No? 7. Then you get this times this, minus plus 1. This times this one, -3 plus 4. Again, 1. Last one. What is the entry here? Fourth row, first column. 3 minus 4. 3 minus 4. What is it? 3 minus 4 is going to be -4 is -1. No? Fourth row. So 3 minus 4 is going to be -1. What is AB? AB transpose. AB is this. Did I make a mistake here? AB is correct.
Sir, first row ke tine එක වෙනව නේද?
කොතනද? කොයි එකේ first row එකද? මෙතනද?
සර් දෙක තියෙන තැන ඍණ එක නේ.
මෙතන දෙක තියෙන තැන. ආහා. AB මෙතන එනවා ඍණ එක. ඍණ එක තමයි හරි. ඒක තමයි මම මේ නැවැත්තුවේ අස්තින්දි. කොහොමද එතන ඍණ එක එන්නේ? බලන්න. මේක වැරදිද?
එතන
මේක නේද? මෙතන. එතන නේද වැරද්ද?
එතනනේ. එතන තමයි මේ පාස් එකේ
first row. මට කියන්න කොතනද මේකේ වැරද්ද තියෙන්නේ කොතනද AB වල? දෙක තියෙන තැන ඍණ එක දෙන්න ඕනේ. දෙක තියෙනවා කියන්නේ මොකද්ද? first row, fourth column. තුනයි. මෙතන තියෙනවා ඍණ එකනේ. Sorry. What is that place? First row, fourth column. First row. මම මේක ගන්න ඇත්තේ. First row, third column, fourth column. First row, fourth column. Multiply first row, fourth column. 3 minus 4. So එතන -1 එන්න ඕනේ. So if it is -1, this should be -1. Anyway, මේක මෙතනත් වරදිනවනේ -1. I hope the other ones are correct. අනිත් ඒවා හරිද? දැන් මෙතෙන්ද යමු. So AB transpose. Now B transpose A transpose. This place is 4th row, first column. 4th row, first column. 3 minus 4. That is minus 1. Minus 1. Method entry. Check that. That is the 4th row, second column. 4th row, second column. Then you multiply these two, you get minus 3. Method entry. I'm sorry. Minus 3. What is the last entry? 4th row, third column. 9 minus 2. That is going to be 7. So A transpose is this. I'm just working with numbers. No? Now that and this are the same. අර මෙතන බලාගෙන තමයි මම මෙතන check කරනකොට වැරදිච්ච හන්ද I was looking at this, you didn't see it, but I knew the answer here should be minus 1 when I multiply these two. So I see the other one there, the answer was not correct, so I knew I had made a mistake. I said that for you also to know when you have made a mistake. Okay, after that you can correct it when you know you have made a mistake. Okay, so these two, A transpose, AB transpose, but that is this matrix that is in the rectangle here. It's the same as this one. Minus 1, 1 minus 1, 3. 1 minus 1, 3, 4, 2, 4 minus 2, 7. 4 minus 2, 7. 7, 1, 1, minus 1, minus 3, 7. 7, 1, 1, minus 1, minus 3, 7. So what is the conclusion? Therefore, AB transpose is equal to B transpose A transpose. It's not A transpose, B transpose. Order should be reversed. So those are the properties of the transpose. And actually, we have done enough to prove them also, except for the last one. Last one, ijth entry is complicated. So some of the entries taken by multiplying the ith row of A by jth column of B. So it gets complicated when you try to prove it in general. We have at least convinced you that that is the right order by taking an example with arbitrary numbers, basically. Okay, so that is about the transpose. All that you need to know about the transpose. Next, there are two special types of matrices which we have not mentioned earlier. Zero matrix. What is a zero matrix? Zero matrix is a matrix whose entries are all zeros. Matrix whose entries are all zeros. So see, this is a zero matrix of zero matrix consisting of one entry, 1 by 1 zero matrix. Then if you take this, this is a zero matrix. All entries are zeros. This is a zero matrix. This is that is a 2 by 2 zero matrix. So we denote it by very elementary thing. Denoted by, it behaves like numbers also. Now it behaves like the number 0. We denote it by O. So O is equal to 0 m by n. O m by n is, so each entry is 0. Properties. A plus O is equal to what? Now when I say plus, you know, sizes of the two matrices must be the same. If this is m by n, this should be m by n. What is your guess? A plus O is this one, every entry is 0. A, let us take A to be Aij m by n. O is 0, m by n. Every entry is 0. When you add them, you add the corresponding entries. A11 plus 0, A12 plus 0, Aij plus 0 is the ijth element. This is equal to, yes, කියන්නකෝ. Is equal to A. Same with minus. A minus O is also equal to A. Third one, 0 times 0 number, 0 times A. Yes. 0 in R. When you multiply, so how do you multiply the entries of a matrix? How you multiply a matrix by a number? You have to multiply every number by every entry in A by that number. So each number, so this, if I multiply this by 5, it is 5 Aij. Every entry gets multiplied by 5. Now this is equal to, yes, this is to get, I guess, if you multiply every entry of A by 0, every entry of A becomes 0. So this is the matrix O. Okay. Fourth one, O times A. O times A. So what should this be? Or if A, if this is M by R0 matrix, this should be R by N. Otherwise you cannot multiply. No, here they are of the same size. Here for this multiplication, this is the number 0. No? So there is no problem. We know how to multiply a matrix by a constant. Here to multiply this matrix by this, the compatibility condition should be satisfied. When that is satisfied, can somebody tell me the answer? O times A, 0. A multiplied from the left hand side by the 0 matrix. What do you think?
0 m by n.
Yeah, that is right. So we can say O. So well, as a matrix, we call it O. O consists of 0 entries. What you said is correct. O m by n. How about the other way around? A O. A time. If you want to, if you think you get confused, you can put a dot in the middle, not here. That is the decimal point. So here. Now here A should be of, say, let us say P by Q. Then O should be of Q by R. Again, when you multiply so you multiply here to get the ijth entry, you multiply the ith row by jth column, as in the dot product. A1, B1, A2, B2, plus, AN, BN. So first here actually R columns are rows. When you multiply any column of this by any row of this, we get 0. Same thing happens here. Here, if I take the first row of A and multiply by the first column here, first column is a 0 column. So every entry gets killed. So that is also O. What is the size?
P by R.
P by R. Okay, so those are the properties of the zero matrix. Then there is another, so that's all you need to know about the zero matrix. Okay, so as I have given enough examples of zero matrices in general. This one is every row 0, 0, 0, 0, 0, yeah, oh, 0, 0, 0, 0, 0, 0, all zeros. That is why if you take any row and multiply it by any column, zeros are the numbers that gets multiplied, killing each and every entry in both cases. Okay, then there is so zero matrices are there. Zero matrices of any order, m by n, is there for us. But to work with it, compatibility condition should be satisfied. If you add in a plus 0 is considered, you know sizes of both must be zero, must be the same. Here the same. Sizes must be the same to subtract. Here any matrix can be multiplied by a number. So that is true for. So if this is m by n, this is also m by n. Here O times A, when you write it, you know the compatibility condition is satisfied here too. So zero matrices are there for any order. Now we go to identity matrix. Identity matrix. It's a special type of a square matrix. Identity matrix. Matrix. Okay. It's a square matrix. Identity matrix. It is a square matrix. What is a square matrix? Number of rows and number of columns are the same. It's a square matrix. It's a square matrix with it's a square matrix. So if it is a square matrix, it should be it should be like A m by n. Ouch! n by n. Square matrix, no, yo. Square matrix. A n by n. Let us write this matrix. Okay. Let us write this square matrix. A11, A12, A1n. Here, A21. Somebody's mic is on. A2n. Let us write the ij. I throw also. AI1, AI2, AI2. Last one, AIN, that is the ith row, and then nth, n rows and n columns, no? AN1, AN2, ANN, ANN. That is a general square matrix of, we say, order n. Order n. What is order n? What is n? It's n by n. So we don't need two numbers to. We don't need two numbers to take its size, mention its size. One number is enough, n by n, square. Square is this, n by n. N by n. So n is called the order of a square matrix. If you say order 5 square matrix, then it is 5 by 5. That is needed only when we talk about the identity matrix. You can use that language for any matrix. It's a square matrix. Square matrix has a diagonal. Square matrices have diagonals. Diagonal is this. There are two diagonals. that we call the diagonal the main diagonal. These are called the diagonal entries. They are, if we think of this as a square, no? So this is a diagonal, this is a diagonal, but this is the main diagonal. Main diagonal. So we just refer to it as the diagonal. Now, what are the diagonal entries? What is the entry here? Ith row, ith column, na? Ith row, ith column. So it should be I. Here, A21, A21. Here, no, AI1, AI2, AII, AIA. So diagonal entries are A11 diagonal. Let us write that also. Diagonal entries. Entries are AII for I going from 1 to ... n. A11, A12, A11, A12, ANN. Okay. Diagonal entries. They can be classified by writing AII. What is an identity matrix? Identity matrix is a matrix whose diagonal entries all equal to 1. Other entries all zeros. IN, denoted by IN. IN, identity matrix of order n, is the matrix 1, 0, 1, 0, 0, ... 0. 0, 1, 0, ... 0. Next one, 0, 0, 1. And continues. Last one, 0, 0, 0, ... 1. Diagonal entries. They are all 1. Off diagonal entries are all zeros. Is called the identity matrix of order n. Identity matrix of order n. Identity matrix of order n. So how do I write the identity matrix of order n? Another way to say that is, if IN equals, if you take it to be Aij, n by n. If this is the identity matrix, what can you say? AII should be equal to, yes, AII should be equal to what? They should all be 1. 1, 1, for I going from 1 to ... n, and Aij is equal to 0 for all. If these two are equal, then it is 1. Other entries are all zeros. So Aij is equal to 0 for all I not equal to j. Ij going from 1 to n. Okay, another way to write. Or we can say Aij is defined this way. 1 if I is equal to j.
Excuse me, sir.
Yes.
Sir, කලින් කියපු තේරුම.
කොයි මෙතන ටිකද?
ඔව් sir.
දැන් අපි මේක හිතමු මෙහෙමයි කියලා. let us think of IN to be, IN is the identity matrix of order n. This is the notation for, this is the shorthand notation for this matrix. It's a special type of a square matrix where all the diagonal entries equal to 1. Diagonal entries වල form එක මොකද්ද? Diagonal එකේ තියෙනවා කියන්නේ I and j equal. Let us go to this one. Diagonal A11 may ij. A22 ij equal. AII එතනත් ij. Here last one ANN. I and j are equal. So diagonal entries can be identified by I and j. Those are the entries with I equals j. All the other entries I and j are not equal. 2, 1, I1, N1, N2, okay. Here I2, 1, 2, 1, 3, 1, N. For all the other entries, I and j are not equal in the Aij notation. So I want to say the identity matrix is this matrix, this n by n matrix. Identity matrix is a special, only square matrices have diagonals. Look here, rectangle also has a diagonal, but when it comes to the language of matrices, we only talk about diagonals for square matrices. Okay? Sir? Diagonal matrices are there, identity matrices are there only for square matrices because they are the ones having a diagonal. Mn unanam, Mn not equal now 3 1 3 2 again unanam, then this won't be that won't be considered as a diagonal matrix. If the size is 2 3 2 2, there is identity matrix. Identity matrices are there only when the size of the matrix is a size of a square matrix, meaning number of rows and number of columns must be equal. The student asking that question asked, so you understand this is the notation for the nth order identity matrix or identity matrix of order n. Then make a ලියන විදියක් Aij දාලා තමයි මේ කියන්න යන්නේ. We are trying to express this whole thing without writing the matrix with entries. So let us take In to be Aij n by n. In මේක නම් මේ විදිහටම වෙන්න එපා. It must be of this form, no, n by n. Now Aij, A11, look at this matrix. A11 is 1, A22 is 1, ANN is 1, A12 not it's 0, A13 0, A1n 0. Here 21, A21 0, A22 is 1. Identity, the diagonal. This one, what is the place? Place is 2 3 0, 2n 0. If I and j are equal, all the entries are ones. All the other entries, they are zeros. Okay, here if you want to write at the one row just before it, it is a 0. Just before it, it's a 0. Okay, only so the one just before that is. Okay, so AII are the entries on the diagonal. I going from 1 to n. So AIIs are always ones. And off diagonal, meaning not on the diagonal. If an entry is not a diagonal entry, Aij representation, in the Aij representation, I is not equal to j. So that's what I wrote here. Aii equals to 1 for I going from 1 to n, saying these entries are all ones. and Aij. If I take Aij with I not equal to j, saying that it is not on the diagonal. If it is not on the diagonal, you can see, I'm describing this matrix. You can see that all the numbers are zeros. Aij is equal to 0 for ij not equal to 1 and I going from 1 to n, j going from 1 to n also. Aij, I not equal to j, I just wrote. Student, ප්‍රශ්නය අපු එක්කෙනාට තේරුණාද?
ඔව් සර් තේරුණා. Thank you.
දැන් එතකොට ඒකම ලියන්න පුළුවන් තව විදිහක් තමයි Aij is equal to 1 if I is equal to j. බලන්න මේ හිතලා. If I is equal to j. Ij, if I and j are equal, it is a diagonal entry. It's 1. 0 if I is not equal to j. Ij going from, for both, Ij going from for I going from 1 to up to n and j also going from 1 to up to n because square matrix. No? So identity matrix is the square matrix with diagonal entries equal to 1 and other entries all 0. Identity matrix is that. It's a special case of let us finish identity matrix and its properties. Identity matrix. It's like 1. See? 0 is like, 0 matrix is like 0 in the number system. Identity matrix imitates the properties of 1. What is the special property of 1? Real number 1. Any real number multiplied by 1 is that real number. A times 1 is that number A, or 1 times A is also equal to 1 times a number is equal to that number. So when multiplied by pardon me. So properties. Say note. I times in times I times A. What is I times A? In times A. Then A should be of n by m. I is n by n. If you multiply any matrix by the identity matrix, what do you think the answer is? Let me take this 2 by 2 identity matrix. Oops. Oops. 1, 0, 0, 1. This is 2 by 2 identity matrix. This is the same as I2. So let us look at I2 times, then take, let us take A to B. This is 2 rows, no? A11, A12, A13, A21, A22, A23. What is that matrix? 2 by 3. What is I2 times A? Then I2 times A. This multiplied by this. What do you get? It will be 2 by 3 also. This is 2 by 2, 2 by 3. So 2 by 3. What is the first entry? A11. Second entry? This times this. A12. This times this. Second. This times this is what? This place.
A21.
A21. What are the other ones? A22, A23. This times this. What is that? This is equal to A. Like 1, number 1. So A I n times A n by n is equal to A n by n. You don't have to write I n, A is enough, equals to A. Okay, that is first property. Same thing. No. Two, same thing will happen if you do A times In. What do you think A times In is? So A should be, what is the size of the matrix A? It should be M by N, no? N. This is In is N by N. So N, then M by N. What is the answer you guess? Can you guess the answer?
M by N.
M by N, what is the matrix? In times A is A. A times In is also
A.
A. Okay, so that is if you just drop the N and say A times I is equal to A. Okay, and then I times A is also equal to A. When you see this, it's not like numbers. Any number can be multiplied by 1, but any matrix cannot be multiplied by I, because to multiply, compatibility condition should be satisfied. When they are satisfied, then A times I is equal to A, I times A is equal to A. Zero matrix, again to multiply, compatibility condition should be there. So zero matrix and identity matrix imitate under certain conditions, under compatibility conditions, imitate the properties of the number 0 and number 1 in the real number system. So let me also mention another thing, diagonal matrix, special types of matrices, diagonal, lot of words, language, diagonal matrices. Diagonal matrices. Entries on the main diagonal are maybe non-zero. All the other entries, 0. Diagonal matrix. Diagonal matrix is also a square matrix. It must be a square matrix. Square matrix. A square matrix with the following property: Aij. So square matrix, it should be n by n. A square matrix Aij n by n is called a diagonal matrix if diagonal matrix, if Aij is equal to 0 for I not equal to j. For I not equal to j. I going from 1 to ... n and j going from 1 to ... n. Because diagonal matrices are there only for square sizes. Example. Now you have to understand this not just by symbols. You have to understand it in actual matrices. So let me give you example. A equals say 2 0 0 minus 1. Is this a diagonal matrix? Diagonal entries need not be 0. I didn't say anything about those. We are saying off diagonal entries must be 0. If an entry is not on the diagonal, it should be 0. So this is a diagonal matrix. A equals 5 0 0 0 2 0 0 0 minus 1. This is also an example of a diagonal matrix. See, off diagonal. These are two triangles there, no? When you take square matrices, it can be divided into three parts. Below the diagonal, above the diagonal, and the diagonal. Above and below must consist of zero entries. Even zero matrix is also a diagonal matrix. 0 n by n. It has to be n by n to talk about diagonal. Okay, diagonal matrices play a special role. It's easy to multiply a matrix by a diagonal matrix because most of the off-diagonal entries are all zeros. Okay, this is a diagonal matrix. How about this? This is a diagonal matrix. This is a diagonal matrix. If I take A to B, say 2, 0, 0, minus 1, 0, minus 1, 3, 0, 0, 0, 5. Is this a diagonal matrix? Students? Here, this triangle above consists of zeros. Triangle below, are they all zeros? Diagonal, you can have anything. This one is not a zero. Therefore, this is not allowed for a diagonal matrix. It's a 3 by 3, all right. But off diagonal, I not equal to j. This is A21. A21 should be 0 if it is diagonal. This is not diagonal. Not a diagonal matrix. Not a diagonal. The above two are diagonal matrices. Do you understand it? Diagonal matrix. Sure. So many names. No? Then there is this upper triangular and lower triangular. There are two other types of matrices. Nothing, not a burden for the mind, brain that much, because just the memory power is required here. We are just defining things. Zero matrix, identity matrix, diagonal matrix. Two other things are necessary. Upper triangular matrices and lower triangular matrices. Upper triangular. So let us start with upper, lower, triangular, TRIAN, triangular, TU, triangular matrices, upper triangular matrices. Upper triangular matrices, lower triangular matrices. I have to let us take A again. This is for only for square sizes. Only for square matrices. So let us take A to B, A11, A12, A13, A1n, A21, A22, A23. I'm writing more terms there, not 2n. And shall we go to the last one? AN1, AN2. Can somebody tell me the last entry? AN3. What is the last entry? To see whether you are following.
NN.
NN. Yes, we said square matrices, so it should be ANN. Now, in the diagram, let us take the diagonal entries. That is the diagonal. Here, what is the entry just above this one? Just above that, AN minus 1N. There is a triangle here. No? I used the words earlier also having this in mind. Triangle above, I said. Triangle below is this. Okay. This is the upper triangle. This is the lower triangle. Just a minute. Give me just in a minute. Just give me a second. Yeah. Sorry, students, I had to attend to something. Okay. Are you there? 46. Some have left them. Sorry about that. I had to attend to something. So upper triangular, lower triangular matrices are therefore they are only for square matrices again. So this is a n by n square matrix. Okay. Matrix, if these entries are all lower triangle, if they are 0, we say the matrix is upper triangular. So upper triangle and the diagonal. If these are zeros, upper triangular. If these are zeros, we say the matrix is lower triangular. Only upper triangular one is zero. If these are all zeros, equal to zeros, then what is the name given? Upper triangle consists of zeros. So we say the matrix is lower triangular. Lower triangular. Triangular. If these are zeros, we say only non-zero entries are there on the main diagonal or the upper part. Lower triangle consists of zero entries. We say the matrix is upper triangular. Upper triangular. Triangular. So let me give few examples and then write down the precise definition. Let A be say -1, 0, 0, 2, 3, 0, 5, -2, 5, -2, -3. 5, -2, -3. Triangle. Look at this is the main diagonal. Upper triangle consists of zeros. If these are zeros, main diagonal and below entries are all, they can be any entries, but these three entries are zeros. Therefore, this is an example of a lower. It's easy to see. Lower part consists of lower part can have any entries, non-zero or zero. To say lower triangular, upper triangle here must consist of zero. So lower triangular. That is a lower triangular matrix. Then next example, say B is equal to 7, 5, 0, 7, 5, 0, 0, 3, -1, 0, 0, 7. This is an example of a. Look at the diagonal and draw the lower triangle. You see, don't have to draw, just observe. These are zeros. Therefore, this is a upper triangular. Upper triangular. Triangular. Upper triangular matrix. So how do I define it? Using Aij. Upper triangular matrix, let A be equal to Aij n by n. If first one, can call it a definition. First one, if Aij equal to 0 for look at this. I want to first define lower triangular. To be lower triangular, all these must be 0. Look at those entries and observe I and J. For this triangle, I and J, 1, 2, 1, 3, 1, n, 2, 3, 2, n. Next one would be here, a third row, A33, A34, A35. Which one is bigger, I or J? For this part, maybe if I put it there, you will understand it better. Lower triangular, these must be zeros, meaning for Which one is bigger? I or J? For the numbers in here. Which one? J is bigger, no, for every I less than J. For those entries. For these entries, I is equal to J. On the diagonal. On the diagonal, above the diagonal. Below the diagonal, 2, 1. 2, 1. Here, 3, 1, 3, 2. 4, 1, 4, 2. 4, 3. N1, N2. For these numbers, which is bigger? Zeros for I bigger than J. Row number is bigger than the column number in the notation Aij. So if I want to say these are all zeros, I have to say 4, yes. What are those for? I less than J. For I less than J, then for I less than J, we know I goes from 1 to ... n, J going from 1 to ... n. For I less than, then the matrix A is said to be A. So these are all zeros. Then we say it's a lower triangular matrix. Be a lower triangular matrix. Lower triangular matrix. Now define an upper triangular matrix. Second one. Upper triangular. When do we say a matrix is upper triangular? If this matrix, if Aij is equal to 0, can somebody tell me the condition? If Aij equal to 0 for I
Greater than J.
Yeah, I greater than J. I greater than J. And then again, I and J are going from 1 to, that need not be written, we know, but just that is a square for I greater than J, then A is said to be an upper triangular matrix. So we know diagonal matrix. Diagonal is Aij is equal to 0 for all I not equal to J. That is diagonal. Upper triangular here. Lower triangular here. So upper triangular here. Lower triangle is 0. That is why it's said to be upper triangular. Lower triangular. Upper triangle consists of zeros. Okay? So those are the definitions of upper triangular and lower triangular matrices. Okay, now lower triangular. There is this LU decomposition that are needed in application. So you will understand them when you are exposed to them, when you have the knowledge of these definitions. Now, next thing is to talk about inverse of a matrix. Okay, inverse of a matrix. Now, we defined multiplication of matrices. So, so we now know how to add matrices, subtract multiply by a constant, and multiply two matrices. Not any two matrices can be multiplied, but under compatibility conditions, we can do those operations. Now, matrix division, A divided by B is not, we don't divide matrices. A over B, we never write. A over B, we never write. But in a sense, A divided by B is like A multiplied by B inverse. No? For real numbers, that is what it is. No? A over B is defined to be if A and B are real numbers. You can think of matrices as a new type of numbers consisting of array of numbers, no? Rectangular arrays of numbers. That one gadget can be think of as a new type of a number consisting of mn numbers, no? M by n. So AB for real numbers, we know this is A multiplied by B inverse. Like 1 over B is defined here. We don't talk about 1 over a matrix, okay? AB inverse, here only condition is B not equal to 0. So for matrices also, although we never use this notation, never use this notation, okay? Never use that notation. We never use this notation, but we talk about inverses. So we never write capital A over capital B. If I want to do this, I would only write AB inverse. Okay, division of matrices are not defined. We don't denote a division of matrices. Okay, so never divide a matrix by another matrix. Okay, but we can multiply a matrix by its inverse when the compatibility conditions are satisfied. But this notation is not used, okay, for matrices. Addition, subtraction, multiplication is defined by division notation, not even a notation is used. Never, okay? Before I go into this, I think it's better for us to write down some more properties of the operations that we have defined on matrices so far. Okay, let me get, there are lots of properties lots of properties that we need to list, because I said you can think of these matrices as new types of numbers. That's somebody might criticize, how can you call them numbers? Yeah, but new type of numbers, a number consisting of few numbers put in a rectangular array pattern. So we already saw last time for matrices, AB is not equal to, AB need not be equal to BA. When AB and BA are both defined, the AB is not the same as BA. So commutative law for numbers, AB is equal to BA, but not for these new gadgets. AB is not equal to BA, but we can talk about A plus B is equal to B plus C when the compatibility conditions are satisfied. That is commutative property holds for matrix addition, but not for matrix multiplication. So they differ by the property satisfied by real numbers when it comes to the commutative property. But surprisingly, although AB is not equal to BA, A times BC is equal to AB times C. This is the commutative property, commutative, not commutative. Not commutative. What is not commutative? Matrix multiplication. But it is matrix multiplication is associative. Associative is this property, associative, matrix multiplication. Matrix multiplication. Matrix multiplication is associative, but it is not commutative. Okay, so it's surprising because not being commutative, it becomes associative. Let me give an example for this and then write down all the properties and then go to inverse. So let capital A be 1, 2, 3, 4, 0, 1. It's nice that you corrected the error that I made earlier. But it would have been nice if you had unmuted the mic and told me there is an error. It would have been better, but anyway, you were following the lecture. So that is the important thing. 1 minus 1. B is that. And let us say we need 3 matrices for associative property. Third one, we shall take again a 2 by 2 matrix. 1, 0, 2, 3. Verify that Satyapana. Show that it is true. Verify that A times BC is equal to AB times C. Now to talk about this, compatibility condition should be there satisfied for B and C, then A and BC. AB, number of columns of A must be equal to number of rows of B. And then A, B and C, number of columns of AB must be equal to number of columns of, number of columns of AB must be equal to number of rows of C. Compatibility conditions are satisfied. So first one is A is 3 by 2. B is 2 by 2. C is 2 by 2. So can I talk about B times C? Yes, 2 by 2, 2 by 2. No, so 2, 2. 2, 2. BC is defined. Yeah, answer is also B, 2 by 2. 3 by 2, 2 by 2. Defined. AB, A times B, 3 by 2, 2 by 2. Product AB is 3 by 2. This is 3 by 2, C is 2 by 2. 3 by 2, 2 by 2. So all are defined. So let us verify that this is true. A times B, how do I find? So I need first BC. A is given, A is there. Let us write down BC. BC is equal to this times that. 2 times 2. I make mistakes, no? So 4. This one times this, 0, 3. This one times this, 1 minus 2, minus 1. This, 0 minus 3. That is BC. Now I want to do A times BC. What is A times BC? So better write A here. 1, 2, 3, 4, 0. Better to, I want A times BC, so better to write A here. Not there. A times BC. First one here. A is 1, 2, 3, 4, 0, 1. Not there. That would have been better if I want to do BC times A. So A is this, BC is that. So what is A times BC? A is this, BC is that. So A times BC. Multiply this by this. What do you get? 4 minus 2. 2. This times this. 3 minus 6. Minus 3. Then this one times this. 3. 12 minus 4. 12 minus 4 is 8. This times this. 9 minus 12 minus 3. Check, you know. This times this. 0 minus 1. 0, 1. This minus 3. Minus 3 minus 3. So that is A times BC. What we are saying is, although matrix multiplication is not commutative, it is always associative. A times BC is AB times C. Now find AB. Find AB. Use the AB in that order we have. No? So now AB is equal to AB is equal to AB. This times this. 2 times 2. 2 times 2 is 4. AB is going to be 3 by 2. AB. 2 plus 2. 4. This times this. 1 minus 2. Minus 1. 3, 4. This. 6 plus 4. 10. This times this. 3 minus 4. Minus 1. Then this times this. 1. This times that. 0 minus 1. AB is this. Now I want AB times C. Here. A times BC equals AB times C. We know for real numbers this is true. But what is true for real numbers need not be true for matrices. Because of that, AB is not equal to BA. Order in which you multiply matrices is important. So this C is equal to 1, 0, 2, 3. This is 3 by 2. This is 2 by 2. Therefore, we can do AB times. We can do AB times C. Do AB times C. All this you can do it, but just doing them for you to have better practice when I send the tutorial. 4 times. So compatibility condition is satisfied. 4 minus 2. That is 2. 4 0 minus 3. Then second one. This one times this. 10 minus 2. 8. This one times this. 0 minus 3. Last one. This one times this. 1 minus 2 minus 1. This one times this minus 3. See? This is AB times C. This is A times BC. Same matrix. 2 minus 3, 8 minus 3, minus 1, minus 3. 2 minus 3, 8 minus 3, minus 1, minus 3. Therefore, A times BC is equal to AB times C. Okay, that is only for that example. But what we are saying is, it is true in general. Meaning, it is true always. Now, let me write down the properties of these operations. What operations? addition, subtraction, then multiplication by a number, multiplication by a scalar, then matrix multiplication. Okay, so these are the properties of the matrix operations done so far. Properties of matrix operations. Addition, subtraction, multiplication by a scalar, and matrix multiplication. First property. So now we have to say, assume that the sizes of matrices are such that, assume that the sizes of the matrices, plural of matrix, assume that the sizes of the matrices are such that the indicated operations can be performed, are such that the indicated operations can be performed, can be done, can be performed. Assume that, so if I see somewhere A plus B, for that to be defined or performed or to carry out A plus B, size of A must be equal to the size of B. So first property, it requires that A plus B performed. So what are the matrices? This A, B, C are the capital A, capital B, capital C indicates matrices. A plus B matrix is the same as B plus A. Commutative property for addition. That is true. Then commutative. You don't need the word, but may be helpful. Commutative property. Commutative property for addition. That is the operation, addition of. When we say for addition, it is also true for subtraction. Is it? Even for numbers, it is not true, no? A plus B is not, A plus B is equal to B plus A, but A minus B is not equal to B minus A. Okay, so don't put a minus sign here. It's wrong. A plus B equals B. We can add them in any order. Second property, A plus B plus C. Now what are A, B and C? Capital letters indicating matrices, operations plus operation. This is equal to A plus B, A added to B first and the result added to C. This is known as associative property for associative property for addition. Third property, A times BC is equal to, can somebody say? See, I purposely, now I mentioned for addition, commutative property and associative property. ASSOCIATIV. I purposely avoid commutative property for multiplication because we know A times B need not be equal to B times A. that we gave an example last time. Okay. So therefore, we cannot have as a property. It's like for A minus B equals B minus A is not a property. That is not true. Multiplication, even A times B equals B times A is not true. Yes, for some examples, it may be true. When we say we can find one bad place, we say the thing is not valid. So matrix multiplication is not commutative. To make that statement, you need to find only one example where A times B is not equal to B times A. We gave such an example last time, so we don't have to repeat it. A times BC is equal to, yes, is the matrix, yeah, say it.
AB times C.
AB, yes, that is the nice way to say it. AB times C, indicating that AB is done first and then C. So this is the associative property for multiplication. That is there, associative property for multiplication. For multiplication is true. Then third one is that. Then fourth one is A times B plus C. What do you think this is? A times B plus C is equal to, for numbers, A times B plus A times C. That is true for matrices also. AB plus AC. So that is called distributive law, distributive property. Distributive property for multiplication, multiplication over addition. Just say distributive property. You can multiply like that. Property, distributive property. TITY, distributive property. Then we can even do it. Now, AB is not equal to BA. No? So we have to be careful. When you state it this way, we are saying when you multiply from the left a sum, answer is AB plus AC. How about the other way around? A plus B times C. A plus B times C, when the compatibility conditions are satisfied. What is the answer? AC plus distributive property is there that way also. AC plus BC. You can be sloppy and write AC instead of AC, CA. Suppose you wrote CA and think, okay, they are the same. We leave with there. That's wrong, because AC need not be equal to CA. So that is the, so VII, A times B minus C. Subtraction AB minus AC. VII, eighth property, A minus B. Now this A and this B are different. Here compatibility condition should be between A and B minus C. B and C must be of the same size, and number of columns of A must be equal to number of rows of B minus C. Here A and B must be of the same size, and we put C there. We have said no here. What time? 58, yes. Quickly. What is the answer? Can somebody say?
AC minus BC.
AC minus BC, in that order. AC minus BC. Then we come for multiplication by a scalar. Simple A times B plus C, or A plus B is equal to, this A is a scalar, simple letter used. Simple letter scalar, capital letters matrices in this. So this is equal to A times B plus A times C. A times B plus A times C. Now, that is property 9, property 10, A times B minus C also the same, you will see. So you can multiply by a scalar, sum or a difference, and do that in the same order with multiplication by the scalar A. Then A plus B. A plus B, now both times C, capital C, equals, what is the answer? A plus B times C. A and B are numbers. A times C plus B times C. A minus B times C is again true. AC minus BC, 59, AC minus BC. This is 12, 13, 13. AB times C is equal to A times BC. These are obvious properties, but we have to be careful. Not everything that is true for real numbers gets carried over to matrices. Last property, 14. Last property is A times BC is equal to AB times C. AB equal to AB times C. Also equal to B times, yes, B times this A can be put there also. Scalar is simple letters, lowercase for scalars. Otherwise, scalars. Uppercase, lowercase can simple letters. Uppercase letters for matrices in this list for matrices. Matrices. It's 10-1. Okay, so we shall stop there. What is today's date? Today is 15th. Yes, 15th. Today is the deadline for the submission for tutorial 1. Yes, students who have lectures, please leave. Others will tell you. කවදද submit කරන්න ඕනේ? අද නේද?
Oh, sir.
Oh, so I will send you by tomorrow to practice. මේක කරේ නැත්නම් ගොඩ ලේසි වැඩි වුණාමත් ප්‍රශ්නේනේ, right? But there are lots of new words because it's a new type of gadgets, mathematical entities that we are dealing with. So needs practice, just practice actually, I think. So I will send tutorial number 2 by tomorrow, okay? So, yes, tomorrow there is a dansala also, no?
Excuse me, sir?
Huh? Dansala තියෙනවා මේවා විතරයි මොනවාද මේ soft drinks කියලා හෙට එකටද කොහෙද 12ටද ඒවයි ඔයගොල්ලෝ ටෙක්නොලොජි ෆැකල්ටි එකේ ඉස්සරහ හරි අපි එහෙනම් දැන් නවත්තමු මොනවාද තියෙනවද අහන්න මගෙන් ලෙක්චර්ස් තියෙනවා යන්න ලීව් කරන්න
Sir, tutorial discussion එක.
ඔව් ඒකට ටයිම් එකක් දාගන්නවා මේ ඔයගොල්ලන්ගේ ටයිම් ටේබල් එකෙන් ඔක්කොටම පුළුවන් වෙලාවක් මේ මිස් සනුරි තමයි කරන්නේ අපි ඒක ගැන කතා කරලා තියෙන්නේ සනුරි කිව්වා දානවා කියලා වෙලාවක් මම අහලා බලන්නම් දාලා නැහැ නේද වෙලාවක් ඒකනේ කියන්නේ කීයද හොඳ වෙලාව ඔයගොල්ලන්ට කියන්න පුළුවන් හොඳ වෙලාවක් තියනවද ඔක්කොල්ටම ෆ්‍රී වෙලාවක් දන්නේ නැහැ නේද නිශ්ශබ්දතාවයෙන් කියන්න දන්නේ නැහැ කියලා වෙන්න ඕනේ ඔව් ඒක කරන්නම්. තව මොනවාද තියෙන ප්‍රශ්න? මේක අප්ලෝඩ් කරන්න ඕනේ අදම. ඔව් මම දැන් කරලා යන්නම්. I'm going to go there. මේ නුවර ඉන්නේ තාම. හරිද එහෙනම්? right. ඔයගොල්ලෝ දැන් faculty එකේ ඉන්නේ. ඔව්. එහෙනම් මම තියන්නම් ඈ. We'll stop. Okay? Bye. Okay.